Okay, ladies and gentlemen, I'm going to show you a couple extra things now. Um, this is the same graph that you saw before. I've just rearranged things a little bit. I've made this smaller and put it up in the corner. Um, I actually did the video analysis over again to tighten up this data. So you can do that too whenever you get a curve that doesn't look right. You can just erase your data points and do them again. And this is a much better fit. So this is better quality data. So if I had this much done, then I would want to go ahead and in this, and I'd want to say File, um, Save As, and I've called this Flying Dog Toy for no good reason. But I'm going to call this my position graph. So this is one of the things I'm going to want to print, or you're going to want to print. So call it projectile position graph or whatever you want to, and save that, because then you're going to go in and you're going to get a different graph. So the next thing I need to do is I need to do a two-finger click on my graph, and under graph options, I'm going to change the axis out. I'm going to take out the x and the y information. I'm going to put in x velocity and y velocity information. So I'm asking this now to give me velocity graphs rather than position graphs. So I'm going to go in and say OK, and then I get a graph that looks a lot different. So I also need to do a fit on this graph, as I did, sort of like I did on the last one. So I'm going to go in, I'm going to highlight this point right here, right across here, across these blue dots. And this is a fairly linear relationship of the blue dots, and that should make sense, that I'm going to have an object now that is going to be moving in the vertical direction. It's going to accelerate at 9.8 meters per second squared, so its velocity should change at a constant rate. So if I'm looking at the blue dots here, I want to do video analysis for y velocity, because I'm talking about the y information. I click OK, and I get this value right here. And this shows me that I get, this is actually giving me a slope of negative 12.8 meters per second per second. So that's giving me an acceleration that's larger than the acceleration of gravity. So I've made some kind of an error on that. Yours, when you do this, should give you an acceleration of close to 9.8 meters per second, or 10. My image was blurred a lot. Yours hopefully won't be blurred as much. So you'll be able to get a better quality piece of data for that. The next thing I want to do is I want to go in and do the same sort of thing, but I want to do it now with my X information. So these look relatively linear right in here. So I'm going to highlight this section right in here, and I'm going to get let's go ahead and grab all of it. It's not going to be the best quality, but it'll be all right. So I've highlighted all of these little red triangles. And now I'm going to tell it that I want a linear fit again. So I chose the linear fit option, and I'm doing this now to the X information. So I'm going to say OK, and I get a second box right here. And then this gives me the vertical velocity, or excuse me, the horizontal velocity. So this shows me that I have a slope of this line of -1. I should actually want a slope of this line of close to 0. So that's also another bit of an error, because if it's constant velocity, then I should have darn near a 0 slope. Let's go ahead and I'm gonna X this out, and I'm gonna do it again. Maybe I'm not. Yeah, I guess not. This is not perfect. As I said, hopefully your data will be better quality than this. This should be a completely flat line to show a 0 velocity, but it's not. It shows a it shows a little bit of acceleration. But this y-intercept right here, the value for b shows me that I have a side-to-side velocity of about 3.019 meters per second. So that's the velocity in the x direction. That's my side-to-side velocity. Okay, this is the other thing you need to print. So I will go here and I'd say File, and I'd say save as, and I would call this flying dog velocity graph. Okay, so there we go, velocity graph. Oops, I spell it right. And I'd save that, and then my partner and I need to print this. So you're going to print this graph, and you're also going to print the other one. You can go ahead and do this. When you have it this way, you can say print graph. This would send it, so I would do all that good stuff. Say okay, and I send it to the printer. So there's my print graph option, and then I go in, do the file, open recent, open up the dog position one, do the same thing, file, print graph, and I get the hard copies that I need of these graphs. So that's ultimately you're going to be your goal. Oh, well, I'm at home, so it's not letting me print, but ultimately that's your goal, to get these things printed so you can then make the poster with your partner. But you have to make sure that you have saved these files so you can go back and pull data off of them. All right, thanks you guys. Good luck getting this done. I'll be around to help you in class if you need it.